We are back again with the trip related to gradient change. A quick gradient change in pressure can be considered dangerous for the compressor. If gradient change is more than 600 millibar per cycle and less than minus 600 millibar per cycle in two successive PLC cycles, each cycle is 100 milliseconds as an example, you can consider it less than 100. This considered as an abnormal state. If in a window of 10 seconds, two abnormal states can be considered as surge alarm, while 5 normal conditions are considered surge trip. If in the window the number of abnormal conditions doesn't reach the critical value of 5, the trip threshold, the alarm and internal registers are initial as R. All parameters should be changeable or variable and can be altered by commissioning engineer. So in order to be able to simulate this surge, this type of surge, you can see that the vent valve is closing. We get the flow from the inlet guide vane, compress and send that to the header. If we have some problems in the header, some turbulence in the header, because the header will transfer the liquid in the gas, the compressed gas in a remote area. If some turbulence happens here, the turbulence will be transferred here, and the turbulence will damage the blades and mechanical parts. So we need to have in order to simulate this condition, we created oscillation in the Luft function block. When I increase this variable, this is the a variable in the Luft block. Let me find the Luft block. In the Luft block, this is the variable a here. You change this variable and you can see that we have the oscillation. Let me increase the oscillation here and function test by moving to part C here and go online. So the gradient should reach to 600 millibar per cycle. The cycle is 0.1 second. The cycle should reach to 6,000. So I need to increase the oscillation a bit more. Let me see. The window is 100 seconds. I just increased the window to have time to react, and the gradient number of dangerous gradient change is considered to be 20. This is very dangerous. Even in a function test, in a simulated function test, we are reaching to danger. The surge is detected. The surge is detected here. You can see that the surge alarm is detected. I stop the oscillation. the surge alarm is detected, we didn't reach to the shutdown. It's a very quick phenomenon. You can see the number of gradient changes 4. We consider to the max number of gradient change that caused the shutdown is 20, and the window is 100. So we didn't reach to the shutdown threshold. I consider 0.2 a number of the 0.2 or 0.2 multiplied by the max number of gradient, that is 4. The window is 100. We didn't reach to the max 20. 4 is sufficient to generate the alarm. So if we reach to 100, the alarm should be removed. The alarm should be removed, and the number will be reset. The watch also will be reset, and the alarm signal is also reset. So we are ready to generate, or we are ready to monitor again. For a normal condition, the window can be considered 10, and the number of gradients should be limited to 5 for a realistic condition. The alarm is also possible to be ignored here. So surge will shut down the compressor in order to protect the device. So we need to watch what will happen. Let me increase it a bit here. That's we have the surge, and 20. We will pass the 20 here, so we have the shutdown. So the compressor is in shutdown status due to surge. The reason is high oscillation in the discharge pressure, and it's an indication of mechanical damage. If it's on the compressor for a long period of time, we will damage the compressor. We need to acknowledge